In this type of projectile motion, the object now travels at an initial velocity. However, this initial velocity has a vertical and a horizontal component. It's traveling at an angle. So, for example, let's say Super Mario Brother here is being launched out of a canyon at 10 meters per second at 45 degrees. Okay? So our first step here, as we said, is we need to break down the velocity into x and y components. So for our x component, we need to multiply 10 meters per second by the cosine of 45 times cosine 45, and that tells us is 7.1 meters per second. And then, so that's the x direction. And then for the y direction is 10 meters per second times the sine of 45. And for us, that number is the same as well, 7.1 meters per second. Okay, so that was step one. Now, step two, we have to use the y velocity to find the total time in the air. And remember, the initial y velocity is equal to the final y velocity, just a different sign. So then we can use the formula A equals Vf minus Vi divided by t. To rearrange for time, we'll get t is Vf minus Vi divided by A. A here, remember, is negative 9.81 meters per second squared. So if you crunch numbers, the answer is 1.44 seconds. So that's step two. Now, step three, we have to use the uniform motion equation, v equals dt, to find our range, the x distance. So we use v equals v times t. Our velocity is not the 10 meters per second, but just the horizontal component here of 7.1 meters per second squared, or 7.1 meters per second, multiplied by our 1.44 seconds, so that our answer is 10.2 meters. So that's part three. Now for part four, we use time and the y velocity to find the maximum height. We can find how high Mario Brother reached in his maximum flight path. However, remember here, this is our total time from our beginning all the way to the end. However, to find the maximum height, we only need to find the time it took to reach up here. The time to reach up to this point would only be half of this time. So I like to call it my time up, or top, is 1.44 seconds divided by 2 equals 0.72 seconds. And then we can finally use this equation, d equals vit plus 1/2 at squared, to find the maximum height. So our distance is our vi. Again, this is our initial y velocity, 7.1 meters per second, times 0.72 seconds, plus 1/2 times negative 9.81, and t is 0.72 seconds. Don't forget the square. I know you can't see the square because I ran a room, but if we were to crunch the math, we'll find our maximum height, or dy max, would be 2.6 meters. So in this type of example where the object is launched at an angle, there's two important things. First, we need to break down the velocity into x and y components. Then we have to treat these two velocities separately. And remember, in the x direction, it's uniform motion, there is no acceleration. However, in the y direction, it is accelerated motion because it's subjected to the rules of gravity. So the acceleration due to gravity is negative 9.81 meters per second squared. Once again, time is the same between the x direction and the y direction in total. However, we only use half the time here because we only wanted to find the maximum height